Hello and welcome. I'm an avatar created by Yili Lin, a health services research PhD student at George Mason University. Today's topic is performing logistic regression analysis in R. Logistic regression is a statistical technique used to model a binary outcome based on one or more predictor variables. Use it to predict the probability of the outcome, using the log odds transformation of the linear relationship between the independent variables and the probability of the outcome. Logistic regression has certain assumptions. First, linearity of logit. Logistic regression does not assume a linear relationship between the predictors and the outcome. Rather, it assumes a linear relationship between the log odds of the outcome and the predictor variables. Each observation should be independent of others, and residuals must also be independent, especially for time series data or data with potential serial correlation. To avoid distorting the significance of individual predictors, multicollinearity should be minimized, ensuring that predictors are not highly correlated with one another. Extreme values or outliers can impact logistic regression results, so it's essential to check for and address them before fitting the model. First step, preparing the data, reads a file and stores it in the data variable. To inspect the data, use head to view the first few rows, str to display the dataset's structure and variable types, summary for basic descriptive statistics to understand the data distribution. Check for and address missing values. Refer to the session on addressing missing values in R. Check assumptions to ensure regression is appropriate for your data. In logistic regression, the dependent variable must be categorical, so confirm your data is formatted correctly. Step 2. Performing regression in R. The GLM function in R fits a logistic regression model with a binary outcome by specifying family is binomial. The summary function provides details on coefficients, standard errors, z-values, and p-values. Step 3. Data interpretation and validation. Verify the details in the session on interpreting logistic regression output in R. Conduct post-analysis assumption tests by checking the residuals to ensure the validity of the results and that the underlying assumptions of the analysis were met. Refer to the session on testing assumptions for regression in R. Predicting outcomes with a logistic regression model involves estimating the probability of an outcome for new or existing data points based on the model's coefficients. The predict function provides predicted probabilities ranging from 0 to 1. A standard threshold of 0.5 is applied. Probabilities above 0.5 indicate the positive class, while those at or below indicate the negative class. The if-else function can create a new vector, predicted classes. Depending on the context, you may adjust this threshold to balance false positives and false negatives. While probabilities help understand risk, converting them to binary outcomes is often necessary for decision-making and performance evaluation. K-fold cross-validation. The data is split into K equal-sized folds. The model is trained on K-1 folds and tested on the remaining fold, repeating this process K times. Train test split. The dataset is divided into two parts, one for training the model and one for testing it, allowing for evaluation on unseen data. Common splits are 70% training and 30% testing, or 80% training and 20% testing. The ROC curve plots the true positive rate against the false positive rate at various threshold settings, visualizing how the model's performance changes. The AUC quantifies the model's overall ability to discriminate between classes, summarizing this ability as the area under the ROC curve. A confusion matrix displays the counts of true positives, true negatives, false positives, and false negatives, enabling the calculation of performance metrics like accuracy, precision, recall, and F1 score by comparing predicted classifications with actual outcomes. Step 4. Communication and reporting. Provide clear interpretations of each coefficient in terms of odds ratios. For example, a coefficient of 0.5 corresponds to an odds ratio of approximately 1.65, the square root of E, indicating that a 1-unit increase in the predictor increases the odds of the outcome by 65%. Additionally, report metrics such as accuracy, precision, recall, F1 score, the ROC curve, and AUC to summarize the model's performance, along with the confusion matrix. Clearly state the assumptions of logistic regression and how they were tested, while also discussing limitations. Display the ROC curve and report the AUC to illustrate the model's discriminative ability. Use histograms or density plots of predicted probabilities to show predictions across the dataset. Present plots of coefficients or odds ratios to clarify the effects of predictors. Relate the model results to practical implications and decisions. Based on the findings, provide actionable recommendations to improve prediction accuracy or target specific interventions derived from the model's predictions. Provide comprehensive documentation that includes data description, model specification, validation methods, and findings. Following these steps ensures a clearer understanding of each phase of logistic regression in R, making the analysis more actionable and effective for decision-making.